Hi, my name is Jen Dixon, and this is my inquiry lesson model. A little bit about what inquiry is. Inquiry approaches are provided to students to allow for natural curiosity and to pique interest through guided or unguided processes. Students are provided with opportunity to actively participate by developing theories and questions through constant investigation in order to reach an appropriate solution. Inquiry lessons allow for students to deepen their understanding of a concept through personal relevance and motivation. This model creates an environment of engagement through collaborative learning opportunities, critical thinking, building of questioning skills, and positively continuing curiosity amongst learners. The purpose of inquiry is for students not to be given a conclusion, but to foster appropriate resolutions to develop questions and issues. Inquiry provides students with a quest for knowledge in order to determine the why of occurrences. An extrinsic motivation is provided, allowing students to use their observations, creating a series of phases moving from hypothesizing to analyzing. Today I will be explaining my lesson amongst the phases of the inquiry model. The topic or the subject of my lesson is the plant life cycle, and how a plant absorbs water. This lesson is intended for second grade students. The standards and objectives are listed. Students will be able to describe the process in which a plant absorbs water. Students will be able to construct questions based on observations, and students will be able to generate and analyze a specific hypothesis. This particular model was chosen for the goal of the specific purpose of motivating students about a common daily occurrence. Water absorption in plants is an activity that we are all aware of, however, we do not visually see it. The inquiry model allows for students to enhance their thinking and expand a simple concept to generate many more findings, opposed to one concrete answer. For this lesson, guided inquiry will be used. Guided inquiry was chosen due to the fact that the teacher can control what the students observe, but also allows freedom in the sense that they can expand and explore the concept. For this lesson, only a few materials are needed. A tall clear jar, large celery stalk with leaves, red food coloring and water, scissors, and an observation and phases recording sheet, as well as a chart for yes and no column. So a little bit about the setup. The teacher will gather students in a common area to provide them with this discrepant event. Teacher will usually, visually, in a step-by-step process, begin the experiment using visuals and audio. Teacher will fill the glass jar with water and the food coloring. Teacher will then trim the bottom of the celery stalk. The celery stalk will be placed in the water, and the jar will then be placed by a window. Phases will then take place. This lesson will serve as an introduction lesson to the life cycle of a plant unit, which will cover the absorption of water stages in more depth. The first phase of the inquiry model is the discrepant event and then confronting the problem. So you'll notice that in my presentation on the left I have description, and this is what will happen in an inquiry lesson, and on the right I have what I will be doing in my lesson. Guided inquiry lessons always begin with the teacher providing a problem that cannot be immediately solved. The discrepant event piques students' interest, which sets up active participation and interest to work towards finding a solution. Teachers providing the discrepant event need to have knowledge of what the students are observing. So for my lesson, this will all happen on day 1 over a series of 2 days. So the discrepant event or motivation of my lesson will be just like the setup that I talked about in the previous slide. The teacher will begin by having students come to a common area where all of the materials are visible. Teacher will fill the jar with water, dropping food coloring in, trim the celery, place the celery in the water, and move it to a location by a window. The teacher will emphasize and describe each piece of material and visually cue as he or she moves from step to step. This discrepant event is age appropriate. As students are observing each step and viewing the materials up close, they are generating questions in their mind and already foreseeing possible conclusions as to what is occurring. They will be informed that the celery is going to remain like this, and then they will view it the following morning. Their task is to come to a conclusion about what they think will occur overnight with the stalk of celery. Kinesthetic movements, interpersonal, intrapersonal, as well as spatial intelligence are all being used within this simple descripant event. Visuals and audio will work towards diversity as well. The teacher will explain to the students that a video camera is going to record the experiment all throughout the night, and then the teacher will create a fast video reel that will allow students to visually view every occurrence that occurred while they were at home. The purpose of this use of technology is for students to be able to view each step that occurred throughout the process of water absorption. This will enhance their positive learning experience. So a little bit about the description of Phase 2 of an inquiry model. Phase 2 is the questioning and the gathering of data. During this phase, students are to generate questions about what they just observed. The questions that the students ask should be structured so that the teacher can answer with a yes or a no. The purpose of this phase is for students to generate possible facts and gather more data prior to creating a hypothesis. So this again will be day 1 of my lesson. In my lesson, students will be prompted to produce questions based on the descripant event that the teacher provided. Teacher will use the think, pair, share model prior to proceeding to whole group discussion. Before discussing with partners, the teacher will remind students that they are to develop questions that the teacher will only be responding with a yes or a no. For this particular lesson, the questions will resemble what they think could potentially happen to the celery while it is in the jar with the food coloring. So example questions that they could come up with is the water touching the celery? Could sunlight or clouds influence the result differently? Did you cut the bottom of the celery in order to help the water move easier? This will ensure that the teacher will only act as a guide in our study, and the teacher will not be providing them with direct answers. However, due to age specifics, the teacher will prompt their questioning. Students will first think about what they viewed. They will then pair with a partner and try to develop possible questions. A group discussion will then occur, allowing students to process what potentially could occur. As questions are being asked and a discussion of possible events is occurring, teacher will be recording the information on a visual chart labeled with a yes column and a no column. This process will create critical thinking experiences. Students will use their cognitive skills to build off of questions, moving the discussion of gathering data in a positive direction. During this phase, constant formative assessment will take place by observing student participation and comments relating to our study and individual and group discussions. Phase 3 of the inquiry model is experimenting and generating the hypothesis. So in this phase of the inquiry model, teacher will encourage students to synthesize the yes column in order to develop a hypothesis about what they view based on the descripant event provided. Teacher will continue to prompt reasoning techniques by continuously asking questions about why they hypothesize what they did. This phase allows for students to defend their ideas and formulate a plausible hypothesis based on the use of data. In my lesson, students will synthesize the yes column and create a hypothesis about what they think will occur overnight with the celery and what the celery will look like when they return to school the following morning. Students will be provided with an experiment sheet where they will write their hypothesis, and they will also explain why they believe this based on the analyzing of data. They will also draw and label a picture of what the celery stalk looks like at that moment. Teacher will view each hypothesis and challenge students to defend why they believe this will occur. Synthesizing the information, summarizing, and coming up with a conclusion from data are all important mind activities relating to reasoning skills. This portion of the lesson will allow for formative assessment to occur to see if students are meeting the objective provided. Phase 4 of the inquiry model is the closure and formulating a hypothesis. So in this phase, hypotheses have been generated and they have been tested. So rejection or validation of each hypothesis will occur. This will occur on day 2 of my lesson. So students will all gather in an area to view the celery stalk. They will then be able to determine whether or not their hypothesis was correct. During this part of the lesson, students will draw and label this phase of the celery stalk. A group discussion will occur sharing whether or not their hypothesis was correct and which data provided on the chart or observable data prompted them to create a correct or incorrect hypothesis. This phase encourages critical thinking and another opportunity to reinforce the concept of reasoning. With every comment, students are encouraged to explain how or why they reached the particular conclusion. This phase will promote bodily, kinesthetic, interpersonal, intrapersonal, spatial intelligence, as well as social development. Formative assessment through observation will take place to see if students are meeting the objective. Phase 5 is the analysis phase. So this phase is the completion part of the inquiry process. Once a valid conclusion of hypotheses takes place, the teacher asks the students to evaluate which data helped them determine the valid hypothesis. The focus of this phase is for students to become more critical consumers of information. So in my lesson, this is when the fast video reel will be shared for students to view occurrences that took place. An overview of how plants absorb water will be explained. Students will write a conclusion paragraph on their experiment sheet. They will be asked to think about what they observed that prompted them to come up with the hypothesis they did. They will also be asked to explain which questions fostered their thinking. During this explanation, students will explain what happened to the celery stalk. This will allow students to recall information from the entire lesson, as well as piece appropriate information together to develop reasoning as to what occurred. This experiment sheet will be used as summative assessment. The teacher will be able to view responses to see if students met specific objectives. This model provided me with many new findings. This model focuses on many main mind and brain techniques, as well as allows for many methods of differentiation. I particularly like how this model encourages students to think outside the box, build off of one another through cooperation, and enhance past schema. While teaching this lesson, I found that students developed a sense of engagement as soon as I made the celery stalk viewable. Students are intrigued the entire lesson to determine a conclusion and reason as to why specifics occur. The use of hands-on learning and real-life visuals enhance extrinsic motivation. I found deeper, more valuable discussions to occur when motivation visuals were provided. Students were able to take pride and defend their reasoning. This lesson provided many opportunities to address diverse learners through cognitive processing, building off of past schema, visuals, auditory, and communication with others. This inquiry lesson served as motivation while moving on in the unit of a plant life cycle. This model fosters reasoning skills and enhances opportunity for problem-solving techniques as well as critical thinking skills. It provides students with opportunity to piece information together in order to create and defend their reasoning.